Hey, Hux. We're still looking at how is energy obtained from a chemical reaction. Remember, these are four of our five chemical reactions. But today we're going to talk about predicting products. Okay. Your learning target is I will predict the products of a chemical reaction when given the reactants and the five basic reaction types. Okay. So here are your five basic reaction types, the same ones that we talked about during the last lesson. Basically, what we want to do is we want to say, if I take these two reactants and put them together, what am I going to get coming out of it, right? And the reason for that is that we need to discover new compounds. And so when we want to discover those compounds, we have to predict the products. So way back when somebody was trying to come up with aspirin, they had to figure out, if I put this chemical and this chemical together, what am I going to get? What chemical am I going to get? Okay. So in order to be able to tell whether what I'm mixing together is going to get me what I want. Okay. So there are some exceptions that you have to think about. There are times when, especially in the replacement type reactions, that those reactions just don't work. And the first type is that the metal isn't always replaced by another metal. So if you're using, two metals here in A and C, and you're trying to get them to flip with each other, there are times when that just won't work. And that's because the one metal needs to be more reactive than the other. And so basically what needs to happen is, if you want to replace hydrogen with the zinc has to be more reactive than the hydrogen, right? So if you're looking at this list, these are the most common types that we would use. The one that you are trying to the one that you're trying to add has to be up higher on the list than the one that you're trying to take away. Okay. And the same thing goes for the four halogens: chlorine, fluorine, bromine, and iodine. But we don't necessarily look at those quite so closely. Okay. And then the second exception that we have to think about is that the compound's formed by a neutral ionic compound, right? So, if we're going to use ions, an ionic compound for each of these A, B, and C, D, we have to keep in mind what those subscripts are, what those ionic charges are, so that when we put them back together, they're put back together correctly. Okay. So even though in this reaction you might have A2B, over here you may not necessarily have an A2, because D may not be a 2 minus ion. Okay. We're going to go through one of those. Okay. So and here's the one that I said we were going to go through. So I have zinc and hydrochloric acid, hydrochloride, and I want to mix them together. So if I go back and I look up in my list, right, my Z is A and my HCl is BC. So if I go up to my list up here, that matches a single replacement. Okay. So what I need to do is I need to put whatever letter A was, so that was zinc, first, and then put the chlorine second, because that's the C. Okay. And then the B is all by itself, which is H, right? Then I have to correctly write them, right? So I now have them in the correct order. I just need to correctly put them in the right format, right? So since we know that zinc is a +2 and we know that chlorine is a -2, we now have zinc chloride, which is ZnCl2. And we also know that hydrogen is a diatom, right? So we need to make that an H2, okay? So basically what I did was I set up the reactants as ABCs, just like up here, okay? Then I have to look at which one of the reactions is the correct reaction type. Then I replace the ABCs with the correct elements in the correct order, okay? And then if this is a replacement reaction, I just have to check to make sure that the element that is replacing is lower than the one that or the one that's replacing is higher than the one that already existed. So in mine, I have zinc and hydrogen are trying to trade places. So if I look, I say, okay, I'm starting with hydrogen. Anything above hydrogen can replace it. So zinc would work. If we said that this was copper, then that wouldn't work, okay? Because hydrogen is higher up than copper, okay? Check for ionic charges. So we know that HCl is a ionic compound. So we know that our AC has to also be an ionic compound. So you have to make sure that you get those charges right and then do your switch trick. Okay. So then change your ionic charges and write the compound correctly. And then be mindful of diatomic compounds, right? So make sure that you get your hydrogens and your chlorines and that kind of thing correct if they're alone. All right. Let's look at another example. Okay. Your aluminum is your A. Your SO4, the whole thing inside that brackets, is your B. The Ca, or calcium, is your C. And your OH2, OH, the 2 goes on the outside, is D. Okay? So we want to know, what is this going to create, right? We want to know what are the products going to be. So what we want is we want then to change to, let me make this just a little bit smaller so everything fits on the screen. We're going to change to BC plus AD, right? That's the double replacement reaction. Okay, and B is SO4. Nope, that's not right. CB. CB. Okay, sorry. C is calcium. And if we look on the periodic table, the charge of calcium is +2. B is SO4. And if we look in on the back side of your periodic table, this is a -2. And then the A is aluminum. And aluminum on our periodic table is a +3. And then the OH on the back of our periodic table is -1. Then if we put it together correctly and write it correctly, we then have Ca2, SO4, 2. But remember, we can't have both of them being 2s. So we have to reduce them down to just CaSO4 plus. And then this 3 goes here, this 1 goes here. So we have an aluminum and then OH3. Okay. Wow, I really messed up that one. Let's go over another one. All right, so here's one that isn't on this list, and it isn't on that list because it's combustion, right? Combustion just has its own ending, right? So you have this whole thing here is A, right? We're taking a substance and we're adding oxygen, right? That's going to give us water and CO2, right? So there's no thinking there at all. You don't have to worry about what is A and what is B or whatever. If you have an A plus an O2, it's always going to give you water and CO2. Okay. All right, so you should now be able to predict the products of a chemical using the reactants that are given. Okay,